This is Professor Pelton. This is Trigonometry, Chapter 1, Section 4 of Right Triangle Trigonometry. So, trigonometry is defined as the measurement of triangles. The 6 trig functions are given below, and their corresponding abbreviations. So when we look at the triangle, we define the trig functions based on side measures. Okay, it's relative to the angle. So if this is the angle, you have an opposite side and you have two adjacent sides. One of the adjacent sides is called the hypotenuse specifically. The other one is just called a side adjacent. Okay, that'll flip, of course, if you use the other angle. So they typically label them as A, B, and C, although in real word problems they don't use A, B, and C. But however, if it is labeled A, B, and C, C is always the hypotenuse. Okay, and keep in mind it's either this angle or they could make the angle the other one, which is not always not the right-hand angle. So in that case, that is the opposite, that is the hypotenuse, and that is the adjacent. So it just switches basically. Okay, you never use the right angle as the reference angle for the theta. The theta is either the A or the B. So corresponding, the 6 Trig's functions are given as follows: that the sine is the opposite over hypotenuse, the cosine is adjacent over hypotenuse, and the tangent is the opposite over adjacent side lengths for whatever angle that is. And the cosecant, secant, and cotangent, of course, the reciprocals of that. So there are two ways to memorize or remember the ratios. One is the acronym and one is the mnemonic. The acronym is SOHCAHTOA, and the mnemonic is some old hogs come around here and took our apples. Either way, you should know SOHCAHTOA from geometry. Okay, so let's look at a representation here. Given an angle and two sides, which trig function will represent all of the following? Well, if I take any one of these angles, I have the opposite side and the adjacent side. I do not have the hypotenuse. So therefore, this is a tangent function based on the mnemonic of the angle, equals 4.5 over 3. And we can repeat that for all others. So the tangent of theta equals 6 over 4 for this triangle, and the tangent of theta equals 3 over 2 for this triangle, and the tangent of the theta angle is 1.5 over 1. But if you think about it, 1.5 over 1, 3 over 2, 4.5 over 3, and 6 over 4 are all equivalent to 3 over 2, aren't they? If you simplify them, right? 6 over 4 is 3 over 2, right? You do 45 over 30 if you move the decimal, which is 3 over 2, right? And if you do 15 over 10, which is also equal to 3 over 2. Okay, so if I do the inverse tangent to both sides, to any one of these, you'll always get the same answer. Because what you do to one side of the equation, you must do to the other. So I'll do inverse tangent to both sides, which leaves me with the angle is equal to tangent of 3/2, which will not work out perfectly. So it is more accurate to say approximately. Okay? Alright, so let's go to our calculator here real quick. So if I do the tangent inverse of 3 divided by 2, I do get an answer for theta. However, you're like, that's not very much, but you have to pay attention to the degree of the mode of the calculator, which in this case is radians. If I change it to degrees and do the same thing again, so I'll copy and paste, Control-C, Control-V, and I'll do the approximate, which is above the enter, I get 56. So these are both appropriate answers. It depends what you're looking for as far as what you get, and sometimes I'll ask for both. So this is the theta, and this is the theta, except this is radians, and this is degrees. Okay? So what we're seeing here from the notes is these are all equivalent triangles, so it does not matter how far you extend these sides. Okay? The theta angle is always the same. The ratio just scales up, but to equivalent ratio of sides. And that's true of sine, tangent, cotangent, or any of the trig functions. Okay, let's go to the next page. So let's write the 6 trig functions based on the given triangle. So our 6 trig functions are sine, cosine, tangent, cosecant, secant, and cotangent. Alright, we don't have all the sides, we need one of the other sides, c. So c squared equals 5 squared plus 12 squared. So c squared equals 25 plus 144. So c squared equals 169. So if I square root both sides, c equals plus or minus 13, but in this case we only need the positive answer. So if I use this angle here, which is the given angle, that is my opposite. So 5 over 13 is opposite over hypotenuse. And that is my adjacent. So that's adjacent over hypotenuse is cosine. So the last one is tangent, which is opposite over adjacent. Okay? Then do the reciprocals to get the other functions. So you get 13 over 5, 13 over 12, and 13 over 5. Let me fix that 13 there. Okay, pause the video, try the student problem. Alright, so the student problem, we want the same trig functions. And again, we're missing the hypotenuse, so we need c squared equals 3 squared plus 4 squared. So c squared equals 9 plus 16, or c equals 25. So if I square root, I'll get plus or minus 5, but we only need the positive one in this case. So c is 5. So if we do the ratios given this angle, that is my opposite. So opposite over hypotenuse is sine. And adjacent over hypotenuse is cosine. So opposite over adjacent is tangent. We can reciprocate to get the other functions. Okay, let's try the next one. Try the next problem. Okay, write the 6 trig functions. Alright, so in this case we're missing a leg, so c squared equals a squared plus b squared. So 9 equals 1 plus b squared. So if I subtract 1, I get 8. So I square root both sides. So I get the square root of 2 times 2 times 2. So I get a pair of 2's that can come out. So I get 2 root 2 is my side for b. So we'll use this as our reference angle. Opposite over hypotenuse is 1/3. And adjacent over hypotenuse. And then if we do opposite over adjacent, I get 1 over 2 root 2. For the tangent, you can reciprocate for the other 3 trig functions. So I get 3 over 1, 3 over 2 root 2, and 2 root 2 over 1. If the denominator is 1, you don't necessarily need to keep it that way. You can just write 3 or so on and so forth. Alright, pause the video, try the student problem. Okay, so again we're missing a leg in this case. So c squared equals a squared plus b squared. So we get 25 equals 1 plus b squared. So we'll subtract 1, we get 24. So we square root both sides. We get b equals, let's see, 24 is 4 times 6. So 4 times 6, pair of 2's comes out. So we get 2 root 6. Okay, so opposite is 1. So opposite over hypotenuse, adjacent over hypotenuse, and opposite over adjacent. Cram it in there here. So we can flip them over to get the other ones, reciprocate. Okay. Alright, let's try the last example. So we're going to solve the triangle, which means find all the remaining angles and sides. So we know this must be 180 for the triangle sum theorem. So these two must be 90, this one and this one. So therefore the total must be 90 degrees, which gives a total of 180 when you add in the other 90-degree angle. Okay, so if we do this one right here, if we try to do tangent, that's going to give us two variables, so we can't do that. So we have to do sine instead. So the sine of the angle, which is 40 degrees in this case, is the ratio of opposite over hypotenuse. And the cosine of that same angle is going to be adjacent over hypotenuse. So we multiply both sides by 12. 12 times the sine of 40 degrees equals A, and 12 times the cosine of 40 degrees equals B. And in both cases, it's not going to be exact. Oops, that's an A, not a B. Okay, so we're going to use the calculator now. So we have 12 times the sine of 40 degrees. Okay, so make sure that the calculator is in the correct mode. If you're plugging in degrees, it should be in degree mode. If you're plugging in radians, it should be in radian mode. So we get an approximate answer there. And 12 times the cosine 40 degrees. Okay, so each of those are the side lengths, which 2 decimal places is fine. Since we don't know a specified length, they're just going to say units for the label. All measures should be labeled, right? Radians, degrees, and lengths. So 7.71 is fine for the first one. 9.19 is sufficient for the second one. And we can use units as the specified because it's unlabeled. Okay, pause the video, try the student problem. Alright, so given a right triangle, you can draw it any way you want, as long as this is the C. So that's lowercase c. And either one of these can be B or A, it doesn't really matter. So in this case, we'll put B up here for 65 degrees, and which means this is side B, and this is side A for the lowercase letters. Alright, so this means adding them up to 180, that's 25 degrees. So that gives us our 90 degrees total, 180 for the whole triangle. Okay, so we use our 65 as our reference angle for the theta. And what sides do we have? We have the B, which is 17 meters. Okay, so if I do opposite over hypotenuse, that's going to be sine. So the sine of 65 degrees equals opposite over hypotenuse. And if I want the other one, that's going to be adjacent. But I don't want to do adjacent and hypotenuse, because if I do, that's going to be two variables. So I'm going to do adjacent and opposite, so that's going to be tangent. So tangent 65 degrees equals the 17 over A. Okay, so I'm going to multiply both sides by C. So C times the sine of 65 degrees equals 17, and I'll divide by the sine of 65. So C is approximately, and multiply both sides by A. So A times the tangent of 65 equals 17, and divide by the tangent of 65. So A is approximately. Alright, so we need to use our calculator. Since we're plugging in degrees, we need degrees. So sine divided by 65, and 17 divided by 65 takes tangent. Okay, so let's see what we get. We go to our calculator now. Oop, calculator. So 17 divided by the sine of 65, which is in degree mode, so we should be work here, and 17 divided by the tangent of 65. So we get 18.76 and 7.93 units in length for each of those sides. That is a sufficient answer for these here. And that is the end of part 1.